class. This short lecture is about units and we will be doing 4 problems. So from this class onwards, for rest of your chemistry class, we'll be using SI units. SI units means International System of Units. Now the units that we are used to, that's called the English system of units. So we use miles or pounds or Fahrenheit or gallons. So you can see for length, meter is used, for mass, kilogram is used, for temperature, Kelvin is used, and for volume, liter is used. Now, why is this used instead of English units? So over here, you can see the conversions between various units. So 1 kilogram is 2.2 pounds. 1 ounce is 28.35 pounds. So these are different numbers. It's not easy to remember them. On the other hand, if you look at SI units, if you want to go to a bigger number like megameter, or if you want to come to a smaller number like nanometer, you're going to multiply it by 10 raised to a number. So it's much easier to go up and down. So this is going to be something new for the class to get used to using these units. Now, this is a story which a lot of science teachers love to talk about. And this is the story of mismatched units. So this was Mars Climate Orbiter, and it was supposed to go to Mars to collect data about water on Mars, information about Mars. And it was supposed to go and meet with and pretty much join with another component on the surface of Mars. So NASA sent it, and the cost of the mission was $327.6 million, which was lost because the mission was not successful due to units. So what ended up happening is that the orbiter was supposed to go like this. This was the trajectory. It was supposed to go 226 kilometers from the surface of Mars. If it was at this distance, it would gently go down and join with the other part. Instead of that, what it did is it went 57 kilometers from the surface. Now that is too close to the surface. What ended up happening is that it crashed into Mars. And because of that, part of the mission could not be completed. NASA then spent a few years figuring out, and having a report created what ended up happening. Why did this crash? And what it found was that the reason was mismatched units. So one part of NASA was in the UK, and they were using grams. So where is grams? So here's kilogram. They were using grams, whereas the part in the US, they were using pounds. Because of that, in the calculation, there was a difference in the distance, and because of it, crashed. So in our class, we are going to be strictly using SI units. We're going to just use these units. We're not using the English units. And we're now going to do 4 problems where we'll be doing conversions between these units. So here is the first problem. So it says this is the 4th problem. It says convert 7.8 kilometers to miles. So what I want you to do is go ahead and write given to find in ratio. In this question, what is something that's given to you? So what's given to me is 7.8 kilometer. That's the information given to me. What is something we have to find? We have to find the miles. Our final answer should be in miles. And then the next part is ratio. Is there any relationship you can find between that? So if you look over here, we see kilometers is ratio of length. Here is a ratio between kilometer and miles. So take a minute and see if you're able to solve this question. Whenever you see a ratio, go ahead and write it. So I'm going to write kilometers can be written as 1 km. That's the short form, is 0.06214 mile. Now, whenever you have a ratio, you can write it in a numerator and a denominator format. What that means is you can write it as 1 kilometer over 0.6214 miles, or you can write it as 0.6214 miles divided by 1 kilometer. They are both the same thing. So this is how I'm going to solve this problem out. I'm going to write what's given to me, which was 7.8 kilometers. I have to multiply it by something so that my final answer is going to be in miles. So what do I multiply it by? So look at our two options. This is one ratio and this is the other ratio. Which of these could I multiply with so that my kilometers cancel out and I'm just left with miles? So the answer is this one. Because if I write 1 kilometer is 0.6214 miles, what do I find? I find that my kilometers and kilometers cancel out and I'm just left with 0.6214 miles. So take your calculators out and solve this. 7.8 times 6214. So the answer I'm getting is 4.84692. Now let's look at the sig figs in this. So if you look at the sig figs, you will see that there are two sig figs over here. Two sig figs. This is an exact number. What that means is we are not going to use that in our calculations because it just goes on to infinity. So our final answer's sig fig is going to be based on what's given to us, two sig figs. So let's look at our final answer. It's 4.8. Go ahead and look at the number right next to it. It's 4. Since 4 is less than 5, we will not round up. So our final answer is going to be 4.8 miles. So this is how you solve this problem. Let's go ahead and look at the next problem, which is very similar. So our second question is convert 92.5 pounds into kilogram. Pause this video and see if you're able to extract the given and to find. Those should be easy steps. Then go ahead and see if you can find the ratio. Is there anything in mass that gives you a relationship between pounds and kilograms? So this is the ratio we'll be using, kilogram and pounds. So 1 kilogram is equal to 2.205 pounds. So we can write it as 1 kilogram over 2.205 pounds, or we can write 2.205 pounds over 1 kilogram. So let's do the same format. 92.5 pounds times something is going to give us an answer in kilogram. So what should we choose? The first option or the second option? We want the pounds to cancel out. So we should choose the first option because that has pounds in the denominator. So take your calculators out and solve this and see if you can write the answer with the correct number of sig figs. So the answer I get is 41.9501, and it keeps going. So let's look at the sig figs for this question. So as we talked before, this is exact number. So we are not going to decide our sig figs for the answers based on it. So over here, we have three sig figs. So a final answer should also have 3 sig figs. So over here, this is the 3 sig figs. So we look at the number after 9, which is 5, which means we're going to round up. So this 9 ends up becoming 10, So if it becomes 10, it ends up becoming 42.0 kilogram. All right, students, so this is our third question, which is convert 3.2 gallons into liters. So let's write our given to find. So our given is 3.2 gallons. Liters and our ratio, let's find, this is volume. So is there a relationship between gallons and liters? Here it is. So it's going to be 1 gallon is equal to 3.785 liters. So again, we can write it in two different ways. One is going to be 1 gallon over 3.785 liters, or 3.785 liters over 1 gallon. So we write 3.2 gallons. What should be multiplied by so that our answer is in liters? So you should come to the conclusion that it's this one. So let's multiply it out. So I get the answer is 12.11264. So looking at sig figs, we see that we have two sig figs here. This is exact number. We don't use it. So final answer should have two sig figs. So it's just going to be these two numbers. And then we are not going to round up because it's 1. So it's just 12 liters. So with this, we end conversions between English units and imperial units.